Hi gentlemen, this afternoon I'm going through an example of F.2 because I'm not going to be in today. So firstly we are looking at the nth root of unity, so the idea that we are equating that to 1, which I think you can get that pretty straightforward. I've gone through and indicated a process which can be found in the example of the textbook. And what we are looking to simplify it to is this concept of a W-looking Greek symbol, where that is equal to 2 cis of 2k pi over 3 for the cubic, or the third root of unity. In a future question, there's one that looks a little bit more complex, and you'll notice that the left-hand side is a cubed, as was the right-hand question here. But the right-hand side of the equation is not 1, so we must first get that to be 1. So we could rewrite the above line, but 27 could be written as 3 cubed, and then we again write the same thing, but dividing both sides by the 3 cubed. So this divided by 3 is then going to equal 1, and that's where the concept of the unit comes in. So we are then trying to group all of this to get the z complex number by itself. So again, we can group that into a fraction, put it all into a set of brackets, and instead of writing it as 1, we can now write it as cis 2k pi. And then from there it's just using De Moivre's theorem to get z by itself. So the first step would be to get rid of the cubed, can bring into this form, where we end up with something very similar, but in this case the left hand side is a little bit more complex. And then what we have here highlighted is now going to be the same as what our W looking letter is on this hand side, right hand side. So in both cases we can simplify that. And you'll notice that in this section of the nth root of unity, this symbol is used regularly. So I'm just going to do that without explanation. We get z take 2 over 3 is now equal to W. Get z by itself, it would become z equals W times 3 plus 2. The issue with this is that it only takes into consideration one solution for where this W value was cis of 2k pi over 3, where we know from the nth root, and this being a cubic, that we should have 3 roots. So we can write in there that what we're actually looking for is W to the power of n. And then specify the values that n can take. So n must equal 0 would give us the solution of 1, same as what was here, 1 and 2. If you were looking at an original question to the power of 5, then you would know that you'd go 1, 2, 3 and 4 along with 0, but that's common sense. So that is what you should be working on today, continuing or finishing off your chapter 4, ready to begin chapter 2 next lesson. Thank you.